Dear viewers, we have the one more problem from mathematical induction long answer questions for IPE examination. Important question series we discuss this fourth problem. Here you see what is the fourth problem. Show that 2 into 3 plus 3 into 4 plus 4 into 5 plus so on up to n terms. N into n square plus 6n plus 11 by 3. Okay, 2 3 plus 3 4 plus 4 5 plus so on up to n terms is equal to n into n square plus 6n plus 11 by 3 for all n belongs to n. So here you see, here we want to find nth term here, nth term. So here you see, this is the given series 2 3 plus 3 4 plus 4 5 plus so on plus up to n terms, up to n terms is equal to what? N into n square plus 6n plus 11 by 3 is the given. So here two series are there. One is 2, 3, 4, 2, 3, 4 and so on. And other series 3, 4, 5 and so on. In this, what is the nth term? Tn is equal to a plus Tn is equal to a plus n minus 1 into d is the nth term. Here in this series a is equal to first term is equal to 2 and d is equal to t2 minus t1. D is equal to what is t2? 3 minus 2. 3 minus 2 is equal to 1. From this series, A is equal to T1 is equal to 3, D is equal to T2 minus T1 is equal to 4 minus 3 is equal to 1. We have to find first from this one nth term. Tn is equal to A. 2 plus n minus 1 into 1 is equal to 2 plus n minus 1 equal to n plus 1. And from this series, this is Tn is equal to a plus n minus 1, a plus n minus 1 into d is equal to 3 plus n minus 1 into 1. Okay, all of you. So here d is equal to 1, 3 plus n minus 1 equal to n plus 2. This is n plus 2. Then what is the series? You rewrite series 2 into 3 plus 3 into 4 plus 4 into 5 plus so on plus nth term. Here up to n terms, nth term n plus 1 into n plus 2 is equal to n into n square plus 6n plus 11 by 3 is the given series. Okay, all of you. So, we have to prove this series from mathematical induction. So, we have to prove this statement from mathematical induction. This is the solution of the problem. Okay, all of you. Then we have to prove this problem, that as, so you rewrite as problem the given statement 2 into 3 plus 3 4 plus 4 5 plus so on n plus 1 into n plus 2 is equal to n into n square plus 6n plus 11 by 3. So here for n is equal to 1, step 1 for n is equal to 1. What is the statement? LHS that is S of 1 equal to, this is the LHS, 1 plus 1 into 1 plus 2 is equal to 2 into 3 is equal to 6. Okay, then after RHS, RHS, this is RHS, n of n square plus 6n plus 11 by 3 is equal to, n is equal to 1 implies n is equal to 1, 1 into 1 square plus 6 into 1 plus 11 by 3 is equal to 6 plus 11, 17 plus 1, 18 by 3, 3 6 is equal to 6. You see, this is the LHS, this is the RHS. LHS is equal to RHS, therefore we say S of n is true for n is equal to 1. Okay, all of you. Step 1 completed. Then we go for step 2. Then we go for step 2. Step 2. What is step 2? N is equal to KB true. N is equal to KB true. S of K is equal to 2 3 plus 3 4 plus 4 5 plus so on, plus k plus 1 into k plus 2, or k plus 1 k plus 2 is equal to k into k square plus 6k plus 11 by 3. Okay, all of you. This is equation 1, and here step 3. Step 3. So adding both sides k plus 1th term. Okay, all of you. K plus 1th term. K plus 1th term is what? K plus 1 plus 1. K plus 1 plus 2. Okay, all of you. So this is equal to 2 into 3. Here S of k plus 1 is equal to, this is the S of k plus, this is k plus 1 plus 1 into k plus 1 plus 2 is equal to k of k square plus 6k plus 11 by 3 plus, this is k plus 1, k plus 1 plus 1 into k plus 1 plus 2. Okay, all of you. This is equal to, here LCM is 3, k of k square plus 6k plus 11 plus, here this is 3 into k plus 2 into k plus 3. Okay, all of you. This is equal to, k of k square plus 6k plus 11 k square, or this is k into k cube plus 6k square plus 11k plus 3 of k square plus 5k plus 6 by 3. Okay, all of you. Then you have to write, this is, here you have to write. This is equal to, you write this as k cube plus 6k square plus 11k this is equal to k cube plus 6k square plus 11k plus 3k square plus 15k plus 3 6 18 by 3 is equal to k cube plus 6k square plus 3 square 3k square 9k square plus 11k plus 15k 26k plus 18 by 3. Okay, all of you. Then you take the numerator from this fraction. You take numerator from this fraction. Numerator k cube plus 9k square plus 26k plus 18. Okay, all of you. So here if k is equal to minus 1, what is that? Minus 1 whole cube plus 9 into minus 1 whole square plus 26 into minus 1 plus 18. Minus 1 plus 9 minus 26 plus 18. Okay, all of you. This is minus 27 plus 27 equal to 0. So, k plus 1 is 1 factor. K plus 1 is 1 factor. Then, k is equal to minus 1. K is equal to minus 1. This is k cube coefficient, k square coefficient, k coefficient constant. Here this is 1, this is 9, this is 26 and this is 18. 0, 1, minus 1, 1, minus 1. 9 minus 1, 8, minus 8, minus 8, this is plus 18. Minus 1 into 18, minus 18, this is 0. Okay, all of you. Then this is k square coefficient plus 8k plus 18 is the remaining. So what we can written as this k cube plus 9k square plus 26k plus 18 is equal to k plus 1 into k square plus 8k plus 18. You have to write here this one. This one you have to write here. That is, then what is this one? So here this is k plus 1 into k square plus 8k plus 18 by 3. Okay, all of you. Then what we can written as this is n square plus 6n. Here this you write as k plus 1 of k square plus 2k plus 1. K square plus 2k plus 1 plus here 6k plus 6. 6 plus 1 7. What is the remaining? 11 by 3 is equal to k plus 1 of. This is in the form of a plus b whole square. That is k plus 1 whole square plus you take 6 as common, k plus 1 plus 11 by 3. Okay, all of you. Here in n plus k plus 1, n square plus k plus 1 square plus 6 into n plus 6 plus k plus 1 plus 11 by 3 is there. This is S of k plus 1. Okay, all of you. So, n is equal to k be true implies n is equal to k plus 1 true. Okay, then what we will say that, that is n is equal to k by mathematical induction, by the principle of mathematical induction, for all n belongs to capital N, S of n, given statement S of n is true. Okay, all of you, that's all. Thank you for watching my video.